So in this short video, we're going to talk about TransformerXL, and what we'll cover is a brief working of TransformerXL, how is it different from other transformer models, and how does it capture an extended context. About me, I'm Dhruvi Karani, a full-time data scientist and an AI consultant with MarTech Post. Before diving into Transformer or TransformerXL, let's just take a quick intuition of what attention is. So in a sentence with multiple words, each word has a relation to some other word, right? And so let's say the sentence is James is going to New York next month, and if you're learning the representation for New York, it is important that you pay attention to the word going because it's an action, or the word James because he is a person going to that place, right? And not on the words like on or some other less important words. So that's what attention allows you to do, quantify the importance um, to the surrounding words in the sentence. Typically transformers are trained on a language modeling task. This allows them to learn the representation and the language really well, and then it is used for other downstream tasks like name entity recognition or question answering. So the language modeling task roughly looks like this. So for example, if we take the same sentence, James is going to New York next month. Now if I have a fragment, James is going to New York, so the transformer takes this input, or any model, for example even LSTM, takes this input and tries to predict the next word, which is next, right? And the loss is calculated and the gradient is back propagated. In the second fragment, you shift the input by one word. So now the input is going to New York next, and the predicted word is month. So you do the same thing again, calculate loss, calculate gradient, and then back propagate. Now here comes the fixed fragment problem. Traditionally, these models need a fixed size input, right? So let's say you have a batch of 32 sequences. All these sequences should have equal length, right? Now the problem is the information is here restricted to the fragment. Like for example, if I uh, train the second fragment is going to New York next, the gradient is important to the previous fragment as well, because essentially all of this is the part of the same sentence, James is going to New York next month, right? So the learning that happens in the second fragment is kind of important to the first one too, but that does not happen because the information is restricted because of the way data is structured. Now TransformerXL solves it by using the information from the previous fragment and supplying it to the next fragment while training, and in this way the context is not limited to the number of words in the fragment. What it actually does is, when you calculate the hidden states in the previous fragment, you store it and fix it, and when you train your next fragment, the hidden states from the previous fragments are used as an additional information, right? Although the information is supplied, gradients are only calculated in the next fragment. The gradients don't flow to the previous fragments, just the hidden state is used. So this was kind of a brief overview of how TransformerXL works. Hope you got an intuition. For more information, you can always check out the original paper on TransformerXL, which is available on archive. Thank you.